Good morning, Gen Chem 1. How exciting. Hey, today we're going to tackle percent yield. We're going to take what we've just done with our mole ratio and we're going to add one more piece of information to it and try some sample problems. So we're going to take a reaction, figure out how much we could possibly make in a perfect world. And then we're going to add to it, what do you actually make? And that is where percent yield comes in. So this is going to be kind of a repeat of the other videos until the very end when we're going to calculate our percent yield. So let's start our process just like our other videos. Now this one I've worded just awful on purpose so that we can try and navigate it. So we're asked if we produce this much carbon dioxide from the combustion of propane, and then we're told combustion reactions always react with oxygen and produce carbon dioxide and water. Okay, how in the Sam heck do you write that in an equation? All right, well, if you're producing, that's on your product side. So we're going to produce carbon dioxide and water. Whoops, we've seen that before. And then a combustion reaction, that's exactly what that is. You're about to light one of your fossil fuels on fire, in this case, propane. And you have to have oxygen present. And that's how an awful lot of fire retardants work. They smother. They are excluding that oxygen. We'll see that in our next set of videos on limiting reactant. Okay, so we already know once we write out our reaction, let's go ahead and add our amounts on here. We are going to make 273 grams of carbon dioxide, and we are starting with 96.1 grams of propane. All right, you already know what to do. Grab your yoga pants and light a candle. Let's find our balance. We can't do anything until we balance this reaction. Now, I have been ramping up with our complexity, so I have a feeling this one is going to be a little sassy pants to balance. Let's try it. We've got 3 carbons, 8 hydrogens, and 2 oxygens. We've got 1 carbon, 2 hydrogens, and 3 oxygens. This is nowhere near balanced. So let's take a minute and let's balance it. Let's start with the most complicated first. That's our propane. So let's balance those carbons. Let's try to get to 3 carbons on this side. How do we do that? Let's put a 3 there. The second we do that, we have just monkeyed with our oxygens. So how many oxygens do we have now? I count 7. So we've got 6, 7. All right, our carbons are good so far. Let's move on to our hydrogens then. On the reactant side, we have 8. On our product side, we only have 2. So let's see if we can get, oops, I was talking and writing at the same time. Super hard. All right, so let's see if we can get to 8. Let's put a 4 there. Oh, we just monkeyed with oxygen again. Holy crap, so that is 6 and 4, so we're up to 10 oxygens. That is getting real, huh? All right, so then what do we add over here to our oxygens to get all the way balanced? Let's add a 5. Okay, I love it. The first thing we have to do before we even care about what the question is asking, balance the reaction. Remember, we've got trust issues. You can't trust me anymore. I think you can see that in the problems. All right, so I'm going to erase the balance part if you need to take a screenshot. Now we can do some math. All right, these problems are some of my favorite problems. Why? Well, we're given a starting material and a starting amount. I love it. We're given 96.1 grams of propane that we're going to light on fire. And we're given what we actually make in carbon dioxide. So which number do you start with? Well, when we write a reaction as is, and all the calculations we've done so far have started with an amount. And then we've calculated maybe how much we could make in our products. This is our theoretical. This is how much you could possibly make if the stars align and the mood is just right and every single atom on the reactants turns into, rearranges, forms the bonds of the atoms in the products. That is how much you could possibly make. In theory, that's 100% yield. You just made everything you could possibly make. In practice, that never happens. So if you're ever reading some literature and you see something's 100% yield, you know that they're full of crap. Or there was water in their sample. Okay, so if what we've been already calculating is the theoretical, then what is this number? Well, this is something you would have to actually measure in the lab. Somebody would have to give that to you, or you would have to measure that in the lab. That is what you actually make from the reaction. So how do we compare the two? It's very typical to take a percent. So we can't do anything in this example until we actually calculate the theoretical, because we need to compare these two numbers. So let's turn right around and calculate what we already know how to calculate. Let's start with calculating the theoretical. How much could we possibly make from that propane? Now this we already know how to do. Let's take our 96.1 grams of propane. Let's convert it to moles. Okay, let's use our mole ratio. Let's convert it to carbon dioxide, since that's the one that we're going to calculate our percent yield. And now we need to turn that into grams. That's what your answer is in, grams. So let's convert that then to grams. And this will be our theoretical. So let's start there. Let's fill in some numbers. What is our molecular weight to propane? Let's figure that out. We've got 3 carbons, so 3 times our 12.011, plus 8 hydrogens, so 8 times our 0.0079. I get 44.0965. All right, let's put in our mole ratio. For every 3 moles of carbon dioxide, we're going to use 1 mole of propane. And then let's put in our molecular weight of carbon dioxide. That is 1 carbon plus 2 of our oxygens. And I get 44 for this one as well. So I am getting 44.01078. Awesome. Let's put that in on our calculator. I love it. Let's take our 96.1, divide by our 44, times 3, times 44. And I get 287. All right, now we already know we're going to slim that down. How many sig figs are we given? 3. So let's take and round that to 3. I get 288 grams of CO2. All right, put a big star around this one. This is your theoretical. This is, in a perfect world, how much you could make. Okay, but in the real world, that's not actually how much you're going to make. So our actual is less than that, 273 grams. So in chemistry and literature, everywhere we look at our reactions, if you're in industry and you're making stuff, you don't count on 100% yield because it'll never happen. So how we calculate that is we're going to compare what we actually made. So that's given in the problem, that 273 grams. We need to compare that to the theoretical. That was our sparkle pen here. And then we're going to turn it into a percent. So bust out your calculator again. Let's do that. 273 divided by 288 times 100. I get 94.8% yield. So that's actually a pretty good yield. That is awesome. So this is the idea of percent yield. So we basically just took what we learned in our moles and we did one extra step, and that was compare it to the actual. Now, can you figure out this percent yield? Is that something you can guess or you can predict? Heck no. That is up to Mother Nature. This has to come from data. Okay, I love it. Should we try another one? Yay, this is so much fun. Of course we will. All right, let's take a look at this one. All right, we are given, all right, so you produce this much magnesium chloride. I'm going to just write that up there. Magnesium chloride is one of our products. I'm going to write it over here. And I'm going to write it, you know, the right way. That would throw off our calculations. And then we're starting from 1 gram of hydrogen chloride. So let's put that right there. All right, you know the process. Let's take our names and write formulas, and then take the formulas and balance our reaction. Let's find our balance. All right, magnesium hydroxide. Ugh, how do we do that? That is a nice ionic bond. We're going to take our magnesium. Look at your charges. Magnesium is a +2. Our hydroxide is on your common anion sheet as a -1. So that would be a 2. Okay, and then hydrogen chloride, that is a nice covalent. We could say monohydrogen monochloride or hydrogen monochloride. Lots of variations of that. Dihydrogen monoxide, we know that one. And now magnesium chloride. Chloride is a -1. There you go. All right, let's take a minute to balance that. Let me just spell out real quick. We've got 1 magnesium. We've got 2 oxygens, 3 hydrogens, and 1 chlorine. We've got 1 magnesium. We've got 1 oxygen, 2 hydrogens, and 2 chlorines. Not at all balanced. How are we going to fix it? Well, start with the most complicated first. So that's our magnesium hydroxide. Magnesium is fine. Oxygen isn't. So at the very least, let's add a 2 here. Oh, let's color code. Let's see what that does for us. Let's add a 2 there. That brings us up to 2 oxygen. So that's balanced, and that just messed with our hydrogen. So now we've got 4 hydrogens. Okay. So then we've got to come back over here. How do we get to 4 hydrogens? Ooh, we've got hydrogen here and here. Well, let's choose wisely. Let's look at our chlorine and see if we can hit 2 birds with 1 stone. Can we get to 2 chlorines and 4 hydrogens? Yes, if we put a 2 there. Okay, I love it. All right, now we're balanced. So screenshot if you need to. I'm going to erase this part. Our reaction is nice and balanced. I love it. Now let's do the math on it. Let's do some math. Let's take and start with our 1 gram HCl. Let's convert it to moles. Let's take our mole ratio, and now we're comparing to magnesium chloride. So let's do moles of magnesium chloride, moles of HCl, and then let's convert that to grams. Excuse me, it's allergy day today. Grams of HCl. Okay, let's fill in some numbers. What is HCl? Let's add that up. What is chlorine on your periodic table? Grab that. It is 35.45. So I get 36.4579. And then our magnesium chloride, we balance that as 1. Oh, son of a mother, let's go. Wrong spot. Okay. Magnesium chloride is 1, but our HCl is 2. And then let's do our grams of our HCl. That's just not at all what we need, is it? Don't we need magnesium chloride there? All right, how do we add that one up? Magnesium is 24.3050 plus 2 times our chlorine. I get 95.205. I love it. All right, put all this in on your calculator. Let's see what we get. Divided by 2 times 95.205 equals, I get 1 point, and let's go for 2 sig figs. I get 1.3 grams magnesium chloride. All right, sparkle pen this, because this is in a perfect world. This is your theoretical. And now what was our actual? That 0.7 number. So let's calculate our percent yield. And let's divide by our theoretical. How much we could possibly make times 100. And let's figure out our percent yield. I get, ooh, this one's a little lower, 54.5% yield. All right, awesome. Anybody else get that? All right, let's stop for a second here and practice a couple of these. You've got some in your homework, and then I'm going to do one more problem on the next video, and that is a little bit rowdy.